In today's lesson, we're going to learn about parallel and perpendicular lines. To start, let's define parallel lines. Two lines are parallel if and only if they have the same slope and they never intersect. Here's one example of parallel lines. Notice they have the same slope. Here's another example of two parallel lines. Any two vertical lines will be parallel with each other. And notice with parallel lines, they never intersect. Next, let's take a look at some examples of equations of parallel lines. Here are some equations of parallel lines. Remember that parallel lines all have the same slope, 4 in this case. While parallel lines have the same slope, they will have different y-intercepts. Here the y-intercept is -16, here the y-intercept is 3, and here the y-intercept would be 0. You can see that on the graph too. These two parallel lines have the same slope, but their y-intercepts are totally different. Here's this y-intercept and here's this y-intercept. Let's take a look at one more example of a set of parallel lines. Again, parallel lines will have the same slope, but they will have different y-intercepts. Next, let's define and look at some examples of perpendicular lines. We'll start with the definition. Two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals of each other. And we'll talk about what the word opposite reciprocal means in just a minute. First, let's take a look at some graphs of perpendicular lines. Here's one example of perpendicular lines. Notice that perpendicular lines intersect at a 90-degree angle. Here's another example of perpendicular lines. Any horizontal line will be perpendicular to any vertical line. Next, let's take a look at some examples of equations of perpendicular lines. These two equations represent perpendicular lines. We know that because their slopes are opposite reciprocals. What does the word opposite reciprocal mean? If you have the number 1/7, to find its reciprocal, you flip it. That would give us 7/1, so this is the reciprocal. But if we want the opposite reciprocal, we also need to change the sign. So since this was positive, the opposite reciprocal would be negative. And we could simplify this by writing it as just -7. So we see that 1/7 and -7 are opposite reciprocals. So since these equations have slopes that are opposite reciprocals, these are examples of perpendicular lines. Again, just like with parallel lines, perpendicular lines will have different y-intercepts. We can see that on the graph here. These two lines have totally different y-intercepts, and I just made up all of these y-intercepts off the top of my head. You can change those numbers in your examples if you'd like to. The important thing is that perpendicular lines have opposite reciprocals for slopes, and parallel lines will have the same slope. Let's look at one more example of equations of perpendicular lines. Let's say you have the equation y equals -2/3 x minus 7, and you wanted to come up with the equation of a perpendicular line. Well, to find the equation of a perpendicular line, we have to find the opposite reciprocal of the slope. So that means we flip it and change the sign, which would give us a positive 3/2. And then we can make up any y-intercept we want. I'm just going to say 1/4. Next, without graphing, we want to determine whether the graphs of the given linear equations are parallel, perpendicular, or neither. Well, if the two lines are parallel, they must have the same slope, and if they're perpendicular, their slopes must be opposite reciprocals. So we need to identify the slope of line 1 and line 2 so that we can compare them. The easiest way to find the slope is to write in y equals mx plus b form. So I've started by copying down line 1. Now let's rewrite this in y equals mx plus b form by isolating y. To isolate y, let's start by adding 3x. That will leave us with -y is equal to 3x plus 3. We can picture this as a -1 times y. So to isolate y, let's divide by -1. And that will leave us with y is equal to negative 3x minus 3. Now that we've written our line in y equals mx plus b form, we can clearly see that the slope of this line is negative 3. Next, let's rewrite line 2 in y equals mx plus b form so that we can identify the slope. So I've started by copying down the given line 2. Now to write this in y equals mx plus b form, we need to isolate y. There are multiple different ways to do this, but let's practice one of the methods that we learned earlier on in chapter 1. We learned you can multiply by the LCD over 1 in order to get rid of the fractions. So what is the LCD in this case? Well, the denominators here are 6, 2, and the implied denominator here is a 1. So the least common denominator is 6. So we can multiply each term by 6 over 1 in order to get rid of the fractions. First, I multiplied this term by the LCD over 1. Then I multiplied this term by the LCD over 1. And what you do to one side of an equation, you also have to do to the other side to maintain equality. So I also multiplied the 2 by the LCD over 1. Make sure you multiply each and every term by the LCD over 1. Now we can do some canceling and our fractions will disappear. Here the 6's cancel, and we're just left with 1x or x. Here we can take 6 divided by 2 to get 3, and we'll be left with negative 3 times 1, or negative 3y. And on the right side of the equation, we'll be left with 12. Now we've just made this problem a little bit easier to work with because we've gotten rid of all of the fractions. Now we still want to isolate y. So to isolate y, let's subtract x. That will leave us with negative 3y is equal to negative x plus 12. And then let's divide by negative 3. And that will leave us with y is equal to, we can picture this as a negative 1. So negative 1 divided by negative 3 will give us a positive 1/3 x. And 12 divided by negative 3 will give us a negative 4. So now that we've written line 2 in y equals mx plus b form, we can quickly identify the slope, which is 1/3. Now, to determine if these lines are parallel or perpendicular, or neither, we compare the slopes. Negative 3 and 1/3 are opposite reciprocals. Therefore, our lines are perpendicular. If the slopes had been the exact same number, then we would say that our lines are parallel. And if the slopes were not the exact same number, and if they also were not opposite reciprocals, then we would say that the lines are neither parallel nor perpendicular. Next, we're going to find the equation of the line with the given properties, and we're asked to write our answer in slope-intercept form. Remember, slope-intercept form is the y equals mx plus b form. We're trying to find the equation of a line that's parallel to this line and that goes through this given point. If you remember the previous lesson, we discussed that when you're trying to come up with the equation for a line, you first need to determine the slope. So we're going to start by finding the slope of the given line, which is this line right here, by writing it in y equals mx plus b form. So I've started by copying down the given line. To write this in y equals mx plus b form, we need to isolate y. Let's start by subtracting 2x. That will leave us with negative 10y is equal to negative 2x minus 10. Then let's divide by negative 10. And that will leave us with y is equal to negative 2 over negative 10 simplifies to a positive 1/5 x. And negative 10 divided by negative 10 gives us a positive 1. Now, what was the purpose of writing our given line in y equals mx plus b form? We did this because we needed to find the slope. And when your equation is written in y equals mx plus b form, you can quickly identify the slope, which is 1/5 in this case. Now, this was the given line written in y equals mx plus b form, but we're supposed to come up with the equation for a brand new line. Our brand new line needs to be parallel to the given line, and our brand new line needs to go through this specific point. So for step 2, we're going to find the equation for our new line. What information do we have about our new line? Well, we know that our new line is parallel to the given line. We just found that the slope of the given line is 1/5. So if our new line is parallel, it must have the same slope. So our new line has a slope of 1/5. We also know that our new line must go through this point. Now, in chapter 1.6, we learned that if you know the point and a slope, there are two different methods we could use to write our answer in point-slope form. I will show you one of those methods, but if you'd like to review both methods, look back at the chapter 1.6 video. One of the methods we learned to write an equation of a line given a point and a slope is to first start by writing your equation in point-slope form, which is this form here. I started by plugging in 5 for y1, the slope 1/5 for m, and -10 for x1. Now I'm just going to rewrite this minus a negative as a plus. Now we've written an equation for our new line in point-slope form, except the problem asked for slope-intercept form. So the last step is we need to convert this point-slope form to slope-intercept form. To do that, we need to do two things. We need to isolate y, and we need to get rid of these parentheses. Let's start by distributing this 1/5. That will leave us with 1/5 x, and if you take 1/5 times 10, that will give us a positive 2. And then let's bring down the y minus 5. Now to isolate y, let's add 5, and that will leave us with y is equal to 1/5 x plus 7. And we've successfully completed the problem. We've found the equation of a line in slope-intercept form, and this line is parallel to the given line, and this line also goes through this given point. Let's take a look at a slightly different example. For problem B, instead of coming up with a parallel line, we're going to come up with a perpendicular line, but we're going to proceed with the same two steps. In step 1, we need to find the slope of the given line by writing it in y equals mx plus b form. So I've started by copying down the given line. Now, to write this in y equals mx plus b form, there are multiple different correct approaches you could use, but the approach we've been practicing is to multiply by the LCD over 1 to get rid of the fractions. So that's the approach I'm going to show here. To start, the LCD for this problem is 4. So let's go ahead and multiply each term by the LCD over 1, and that'll get rid of the fractions. Okay, I've multiplied this term by the LCD over 1, this term by the LCD over 1, and this term by the LCD over 1. Once we cancel, our fractions will now disappear. This is just 4 times -x, which will give us -4x. Here, the 4's cancel, and we're left with 1y, or y. And over here, the 4's cancel, and we're left with 3. So there we see, by multiplying by the LCD over 1, we've gotten rid of the fractions. Now there's just one last step to isolate y and get this in y equals mx plus b form. We just need to add 4x to both sides. And that will leave us with y is equal to 4x plus 3. Now that it's written in y equals mx plus b form, we can quickly identify the slope of the given line, which is 4. Now we have to come up with the equation of a brand new line. Our brand new line has to be perpendicular to this given line, and our brand new line has to go through this given point. So what information do we have that's going to help us create the equation for the new line? Well, be very careful. The biggest mistake here is that students will say that the slope of their new line must be 4. But if we read the original problem carefully, we see that our new line is supposed to be perpendicular. That means it will not have the same slope as the given line. Instead, its slope will be the opposite reciprocal. So the slope of our given line is 4. To find the opposite reciprocal, we can write this as 4 over 1. And to find the reciprocal means we flip it, which gives us 1/4, and then it's supposed to be the opposite reciprocal, so that means we have to change the sign. Since this was positive, we have to make this negative. So the slope of our new line is negative 1/4, and our new line goes through this given point. So we're going to start by writing our line in point-slope form, which looks like this. We've plugged in -1 for y1, we've plugged in negative 1/4 for m, and we've plugged in 4 for our x1. Then let's rewrite this minus a negative as a plus. Now we've written our line in point-slope form. Now we need to convert it to slope-intercept form. To do that, we need to get rid of the parentheses and isolate y. To start, I'm going to distribute this negative 1/4. Negative 1/4 times x will give us negative 1/4 x. Negative 1/4 times negative 4 will give us a positive 1. And then we'll bring down the y plus 1. Last, to isolate y, let's subtract 1, and that will leave us with y is equal to negative 1/4 x. And these 1's cancel. So we've successfully found the equation of a line that's perpendicular to the given line. Notice their slopes are opposite reciprocals, and that goes through this given point. Again, in chapter 1.6, we learned 2 methods to compute step 2 here. If you prefer to use the other method, you're more than welcome to use that method. And just to note, in y equals mx plus b form, here the slope is 1/5 and the y-intercept is 7. In this y equals mx plus b form, the slope is negative 1/4. What's the y-intercept? Well, we could easily write a plus 0 if we want here, and that makes it a little bit clearer that the y-intercept for this equation is actually 0. So this line would go through the origin. And let's finish off with these last 2 quick examples. We're asked to write the equation of a line that satisfies the given conditions. Our line is supposed to be parallel to this given line and go through this point. Notice the instructions for this problem are very similar to the instructions we saw in the previous problem, but we're going to solve this problem very differently. We learned in chapter 1.6 that if you have a line with the equation x equals a number, that is a vertical line. And if you remember in section 1.6, I recommended if you're asked to come up with the equation of a vertical line, don't try to use the algebraic approach that we learned on the previous page. You're going to run into issues because the slope of a vertical line is undefined, and you can't perform calculations with an undefined value. So instead of using algebraic calculations, when you're dealing with a vertical and horizontal line, I recommend just drawing a picture. It's a real quick way to come up with an equation for your line. So let's draw a picture of the given line. This given line is a vertical line, and it'll go through the x-axis at -2. So this is our given line. Now our new line is parallel. So if our given line is a vertical line, if our new line has to be parallel, it must also be a vertical line. So we know we're going to be drawing another vertical line. And our new line has to go through the ordered pair 7, 5. So let's plot this ordered pair. So our new line has to go through this point, and it has to be parallel to this given line. So our new line will look like this. Now we just have to write the equation of our new line. We learned in chapter 1.6 that any vertical line has the equation x equals, and the number that we put right here is where your graph crosses the x-axis, which is 7. So the equation of a line that's parallel to this line and that goes through this given point is x equals 7. Let's try one last problem. For part B, we're asked to come up with the equation of a line that's perpendicular to this given line and that goes through this point here. We learned in chapter 1.6 that when you have an equation of a line written of the form y equals some number, this means that you're dealing with a horizontal line. And if you're trying to find the equation of a vertical or horizontal line, I recommend you draw a picture. So let's graph this horizontal line. So this is the given line. Now we're supposed to come up with the equation of a new line that's perpendicular to this given line, and our new line must go through this point. Let's start by plotting this point. So our new line must go through this point, and our new line must be perpendicular to this line. So if you have a horizontal line, a perpendicular line will be vertical. So we have to draw a vertical line through this point. This new pink line is perpendicular to the given line, and it also goes through the specified point. Now to write an equation for this new line, we know that any vertical line has the equation x equals a number, and the number that we put here is where the graph crosses the x-axis, which is 3. So our final answer for this problem is x equals 3.